Today, we are looking at the determination of acid value in oils and fats, or in short, in lipids. We'll start our introduction by looking at what acid value is. So when we talk of acid value, it's defined as the number of milligrams of potassium hydroxide required to neutralize the free fatty acid present in a gram of fat. And what we also have to note is that acid value is a measure of the free fatty acids present in fats and oil. And the acid value is determined by directly titrating the oil or fat or lipid in an alcoholic medium against standard potassium hydroxide or sodium hydroxide solution. So this is basically the way to determine the acid value of a lipid. Let us look at the analytical importance of the acid value. The analytical importance of acid value is that it measures the amount of free fatty acids produced either by hydrolysis or oxidation of lipids due to the action of moisture, temperature, light, or the enzyme lipase. The acid value formula. The acid value formula is given as this. So where V is the volume in moles of the standard potassium hydroxide used, the N is the normality of the potassium hydroxide solution, the W is the weight or mass in grams of the sample, which is the lipid used, and the 56.1 is the molecular weight of the potassium hydroxide. So, relationship between concentration and normality. The relationship between concentration and normality is given as this equation. So where the big N is the normality, the small n happens to be the number of moles of the hydroxide or hydrogen ions in solution, and the big M happens to be the molar concentration. Let's start by looking at the test protocol. So we'll start our test method by first looking at the materials or the reagents involved. So the first is phenolphthalein of this concentration. The next is fat solvent, which happens to be equal volumes of 95% ethanol and diethyl ether. We have 0.1 mole per liter of potassium hydroxide. We have both fresh and rancid soya beans oil, and both rancid and fresh fritter of vegetable oil, and both rancid and fresh olive oil, and both rancid and fresh margarine, a beaker and a conical flask, and burette and a retort stand. The method. 1. Accurately weigh 1 gram of your test compound, which is your lipid, into 100 ml Erlenmeyer flask. Add about 10 ml of the fat solvent. Add 1 to 3 drops of phenolphthalein solution. Mix thoroughly and titrate with 0.1 molar potassium hydroxide onto the faint pink color persist for 20 to 30 seconds. So from the picture below here, we can see that this happens to be the color comparison before the free fatty acid titration I've seen over here, and this happens to be the color comparison after free fatty acid titration. And what we also have to note is that the number of millimeters per standard alkaline required, and calculate the acid value of the fat. Now, so this is our assumed table of results showing the titer volume for each of the lipids after subjecting them to titration. So for the rancid soya beans, we have a titer, an average titer volume of 0.275, and the fresh we have 0.100. For the rancid vegetable oil or fried oil, we have a titer volume of 0.30, and for the fresh fried oil we have 0.150. For the rancid olive oil we have 0.200, and the fresh olive oil is 0.125. For the rancid margarine we have 0.225, and for the fresh margarine we have 0.150 from the table. So let us now look at calculations, how to calculate for the acid value of each of the lipid. So first of all, I would like you to note the normality of potassium hydroxide, or how to determine the potassium hydroxide using this chemical equation. So what we can see is that from the chemical equation, potassium hydroxide has the mole of the hydroxide ions. Hence, the concentration and the normality of potassium hydroxide will be the same. And using the equation given earlier as this, where n is the normality, the small n is the number of moles of the hydroxide ions in solution, and big M as the molar concentration of the potassium hydroxide. So we can say that the normality of the potassium hydroxide will be equal to 1 times the 0.5 over here. So hence, then our normality for the potassium hydroxide is 0.5 normal. The acid value equation, as explained earlier, is given as this. So we are now going to substitute our titer volumes into the equation to be able to calculate the acid value for each of the lipids. So for the rancid soya beans, we had an average titer volume of this. So if you are to substitute this value into the equation, we will get an acid value of 1.543 milligrams of potassium per 1 gram. For the fresh soya beans, we will have 0.561 milligrams of potassium per 1 gram. So for the rancid vegetable oil or fried oil, we have 1.683 milligrams of potassium per 1 gram. For the fresh fried oil, we have 0.842 milligrams of potassium hydroxide per 1 gram. So for the rancid olive oil, we have 1.122 milligrams potassium hydroxide per 1 gram. And for the fresh olive oil, we have an acid value of 0.701 milligrams of potassium hydroxide per 1 gram. For the rancid margarine, we have an acid value of 1.262 milligrams of potassium per 1 gram. And for the fresh margarine, we have an acid value of 0.842 milligrams of potassium per 1 gram. And what we also have to note is that we are using per 1 gram in each of the value, because in our protocol we used 1 gram of lipid. So if we happen to use 2 grams, then that means that over here will be per 2 grams. So let us take note of that. Significance of acid value. 1. The acid value determines the amount of free fatty acids in fat. 2. It measures the degree of rancidity. And 3, it checks the quality of fats and oil on storage conditions. And what we also have to note is that edible oils and fats should have an acid value less than 1%, and pharmaceutical oils should contain no acidity. Free fatty acid value. The free fatty acid value expressed in percentage is given as acid value divided by 2, or the volume of potassium hydroxide times the normality of the potassium hydroxide times the molecular weight of the potassium hydroxide, or divided by 2 times the mass of lipid used. And this equation can be written as this, which is volume of potassium hydroxide times the normality of the potassium hydroxide times 28.05, or divided by the mass of lipid used. So we had the 28.05 over here because these two divided the 56.1, so to give us the 28.05. Thank you.